Hi guys, so here are the notes on 5.2, solving systems of linear equations by substitution. I told you guys we have three different ways that we're going to solve linear equations. We've already solved it using graphing. Now we're going to look at substitution, and then in the next video we will look at elimination. So with substitution and elimination, there are some steps for us to follow since we can't just graph these. When in doubt, you guys can always graph. I'm just showing you three different ways that you could do these. But whichever one that you're more comfortable with, you can do that every single time. So our steps for solving by substitution, the first thing we need to do is solve for one of the equations for one of the variables. So we're going to be given two equations, just like last time. We're going to just pick one of them and solve for one of the variables, and it doesn't matter if it's x or y. Then we need to substitute the expression from step 1 into the other equation and solve for the other variable. This is all going to make a lot of sense in a second. And then lastly, substitute the value from step 2 into one of the original equations and solve. So with our practice that we have, it says solve the system of linear equations by substitution, check your solution. So sometimes it'll tell you which one to use. I'm never going to force you to do that. If you are doing your work on substitution and you just really like to graph and that's how you get it right every single time, graph these. I'm not one to tell you who to do or what to do. So 3x plus y equals -5, y equals 2x plus 5. So what they are telling me in my directions is to solve one of the equations for one of the variables. This equation already is. It tells me that y equals 2x plus 5. This equation's already solved for y. So in number 2, step 2, it says substitute the expression from step 1 into the other equation and solve for the other variable. So they're telling me to substitute the equation from step 1 into the other equation. So if y equals 2x plus 5, then this y equals 2x plus 5. So I'm going to rewrite this equation, putting this equation into it. And that's what I'm substituting. I am substituting y for what I know y to be over here. So I have 3x plus 2x plus 5 equals -5. And if that were a minus y, I would just stick everything in parentheses. All of the signs would change. So now I have nothing but x's and I can solve for x. So that's the whole point of substitution, is to try to get it down to one variable. So 3x plus 2x is 5x. Then I have a positive 5 here equals -5. I need to move my 5 over to the other side. So I have 5x equals -10, and whenever I divide both sides by 5, x equals -2. So I've finished up with step 2. It says substitute the expression from step 1 into the other equation and solve for the other variable. So that's what I've done. I have x equals -2. Lastly, I need to substitute the value from step 2 into one of the original equations and solve. So it doesn't matter which one I choose to put -2 back into. They're both going to give me the exact same answer, but it needs to be one of the original equations. So I'm going to put it into this one for absolutely no reason other than it's just right there. So y equals 2 times x, which I know to be -2. Plus 5. 2 times -2 is -4. Plus 5 is 1. So it's telling me that if I were to graph this, which this is a really easy one to graph if that's what you want to do, then my point where they intersect would be -2, 1. And then again, we can check that. 3x, so 3 times -2, plus y, so plus 1, equals negative 5. 3 times negative 2 is negative 6, plus 1 is negative 5. So that one works out. And then this one, y, which is 1, equals 2 times negative 2 plus 5. 2 times negative 2 is negative 4, plus 5 is 1. So that one checks out as well. So my correct answer is negative 2, positive 1. So we are going to continue doing the same steps on the next 3. I may not even do all 3 in the video, but I will definitely go over them pretty quickly for you. So this one, again, my first step is to solve one of the equations for one of the variables. This one is already solved. Y equals 5 plus x, so I can replace that y with 5 plus x. 5 plus x. And now I have this equation here and I can solve for x. The first thing that I need to do is distributive property. Then combine like terms. X equals 0. And then just plugging into this real fast, y equals 5 plus 0, y equals 5. So my answer is 0, 5. And checking it, 2 times 0 is 0, 2 times 5 is 10, 0 plus 10 equals 10, 10 equals 10. 5 equals 5 plus 0, and it does. So that one works out as well. This one is a little bit more difficult, not much, just because I don't have one of the equations solved for one of the variables. It's really easy to do that, and it doesn't always have to be y, that's just what it's been already. So I can solve for x by moving y to the other side. X equals 3 minus y, or negative y plus 3, if that's what you're thinking. So x equals 3 minus y. 3 minus y would be moved in for x. And then you're doing the same process that you did above. You would end up with distributive property and then solving. On letter D, again, I want to solve one of the equations for one of the variables. It doesn't matter which equation, and it doesn't matter which variable. I am going to do this equation, and I will solve for y. So I am going to move 8x to the other side. I have positive 4y equals 1 minus 8x. So if I divide everything by 4, y equals 1/4 minus 2x. I can replace that in here for y and solve. And again, it's going to be just like we did up here. It's going to be put into, or right behind y, and we're going to have to do distributive property and then solve for x. These don't get more difficult other than just solving for a variable. So for the last question, it's a word problem, just like we had in 5.1, but rather than graphing it, we're just going to solve it by substitution. So it says an adult ticket to a museum costs $3 more than a children's ticket. So we're back on tickets. When 200 adult tickets and 100 children's tickets are sold, the total revenue is $2,100. What is the cost of a children's ticket? So again, with my X and a Y, stands for the cost of the tickets. Y is, or X could be child, Y could be adult. And I need to come up with my equations. So it tells me that a adult ticket is $3 more than child's ticket. So an adult ticket, which is Y, is a child's ticket plus $3. There's my first equation. Then it tells me when 200 adult tickets are sold, so 200 times however much that is and 100, so and plus 100 children's tickets are sold, the total revenue is $2,100. There's my other equation. So again, substitution, y is already solved. If we wanted to graph this, this would be easy to graph. But y equals x plus 3, so this y should equal x plus 3. 200 times x plus 3 plus 100 x equals 2100. So now as we solve this, what we're solving for here is x. That's the only thing I have left in this equation. And it just so happens that x is a child's ticket, and that's what we're looking for. If we're not, we could do one of two things. We could continue to solve for x and then solve for y if that's what they were asking for, was the adult. Or we could have moved this 3 over and solved for y just by getting rid of that x. So whatever they're asking for, you can always come up with the answer the first time if you do just a little bit of planning. So now with my distributive property, I have 200x plus 600 plus 100x equals 2100. So now I need to combine like terms. Then I need to subtract 600 from both sides. Then I need to divide both sides by 300. And this is telling me that the cost of a children's ticket is $5. Alrighty guys, that is the end of these notes. I hope that they are easy to understand if you had missed, because we did this in class together. But if you have any questions, please let me know. See ya.